8.4, using random samples to compare populations. In this section, we will use random samples and compare them to see if we can draw any conclusions about the population. So in this situation here, we have 2 bags that contain 1,000 numbered tiles, and we're going to use a double box and whisker plot to show what numbered tiles we pulled from a sample of 12 from each bag. We're going to compare these samples using the measures of center and variation, and then ask ourselves if we can determine which bag contains tiles with greater numbers. Okay, so let's look at the box and whisker plot. We have 2, one for bag A and one for bag B. And it says to compare using the measures of center. Remember, the measures of center on a box and whisker plot is the median. It's that center line. So in our example here, the median for bag A is 4. The median for bag B is 3. And then if we calculate IQR for bag A, 6 minus 3 is 3, and 5 minus 2 is also 3. So from this, we can conclude that the variation, IQR, is about the same for each sample. But bag A has a slightly larger median. Okay, but how many tiles are in each bag? 1,000. And how many did we pull for the sample? 12. So we cannot conclude anything because our sample size is too small. So the lesson here is to use larger random samples or more random samples, which leads us to our next slide, which is using multiple random samples. And in this situation, we have a double whisker plot, which represents the medians of 50 random samples of 12 numbers from each bag in our last slide. So that means from each bag, we pulled 12 numbers 50 times and then recorded those numbers, right? And then found the median of those values. Okay, so that's what these numbers represent. So we're going to compare the variability of the sample medians and the variability of the samples in example 1. And then we're going to determine which bag now contains tiles with greater numbers. And it should be a little easier since we have a larger random sample. Okay, so looking at our 2 bags, remember 50 different times, so we pulled 12 numbers from each bag. So for this one here, for bag A, the median is 5.5. For bag B, 3.5. And then the IQR that we have for bag A, 6 minus 5 is 1. And for bag B, 4 minus 3 is also 1. So again, the variability remains about the same, right? All right. The other thing is then to look at determining which bag contains the tiles with greater numbers. Well, since bag A's median is higher than bag B's, we can conclude that bag A has tiles with greater numbers. Again, we can do that because we chose 50 random samples of 12 numbers from each bag. So we have a large random sample. Okay, so now you have, I think, one practice problem to do, and you are going to compare 2 dot plots. All right, so here we have our practice problem where we have a double dot plot, which is showing the weekly reading habits of a random sample of 10 students in 2 schools. Okay, we're going to compare the samples using measures of center and variation, meaning we need to find the mean because we're using a dot plot, and we need to use the MAD because again, we're using a dot plot. And then once we find those, we should be able to determine which school's students read less. Okay, so first you need, excuse me, to calculate the mean. Remember, the mean is the average. So you need to add up all these. So this is 0, this is 0. So let me help you with this first one. For school A, our values are 0, 0, 1, 2, 2, 3, 3, 4, 5, and 5. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10. So you need to add all these, and then you need to divide it by 10. That will give you the mean for school A. Then you do the same for here, and that will give you the mean for school B. Then to calculate the MAD for each school, let's say our mean is, for example, the mean is 3 for school A. So now you need to calculate the MAD, and you need to do, 3 minus 0 is 3. That takes care of that one. Another 3. 3 minus 1 is 2. 3 minus 2 is 1. 3 minus 3 is 0. 3 minus 1 is, 3 minus 4 is 1. 3 minus 5, absolute value of that is what? 2. Okay, so you add all those, right? And then divide that sum by 10, and that will give you your MAD. Okay, so once you have those, then you need to ask yourself, can you determine which school students read less? In theory, you should look to see and compare the means. However, with this situation, how many students are we sampling from two schools, from each of the two schools? We're only doing 10. So ask yourself, is that a large number? Does that make our sample representative? Is it unbiased? So question is, can you determine the school where the students read the least amount? And that is it for 8.4.